The arm was fake. It was not connected to a body. It had no nerves, no muscles, and no way to feel pain. But when scientists pinched it, the octopus reacted as though it had been attacked. Its body changed color, its real arm pulled back, and in some trials, it tried to escape. For a few seconds, an animal whose body is almost completely different from ours may have accepted a piece of soft gel as part of itself. But that reaction creates a much stranger question. How does an octopus know where its own body ends? Because unlike you, an octopus does not have two hands controlled by one familiar brain. It has 8 flexible arms, hundreds of suckers, and a nervous system so unusual that much of its processing happens outside its central brain. And yet, in a laboratory in Japan, scientists appear to have fooled that nervous system using the same illusion that tricks human beings. This is Wild Mind Files. Today, we are entering one of the strangest experiments ever performed on an octopus, an experiment that may reveal how an animal with no bones, no fixed body shape, and 8 partly independent arms experiences its own body. And the most surprising part is not that the illusion worked, it is what had to happen inside the octopus before the fake arm could feel real. Part 1. The hand that becomes yours. Before scientists tried this experiment on an octopus, they had already used it to confuse the human brain. The setup is simple. A person places one real hand behind a screen where they cannot see it. A realistic rubber hand is placed in front of them. Then an experimenter begins stroking both hands at exactly the same time. The person sees the rubber hand being touched. At the same moment, they feel a touch on their real hidden hand. The brain receives 2 signals. The eyes say, "That visible hand is being touched." The skin says, "I can feel that touch." If enough perfectly synchronized strokes, something strange can happen. The brain combines those signals and begins treating the rubber hand as though it belongs to the body. The person knows logically that the hand is fake, but when someone suddenly threatens the rubber hand with a knife or hammer, the body can still react. The fake hand has entered the brain's map of the self. This is known as the rubber hand illusion. It's been demonstrated in humans and studied in some other mammals, but an octopus is not a mammal. Its body and nervous system separated from ours through an enormous stretch of evolutionary history. So, scientists faced a bizarre question. Could the same illusion work on a creature whose arm does not even behave like a human arm? To find out, they first had to build an arm that could fool an octopus.
Part 2. Building the Fake Octopus Arm. Researchers Sumire Kawashima and Yuzuru Ikeda worked with a species called the plain-bodied octopus. They created a model arm from a soft, gel-like material and attached it beside an opaque partition inside an experimental tank. The partition served an important purpose. One of the octopus's real arms was positioned behind it, hidden from the animal's view. In front of the partition, where the octopus could clearly see it, was the artificial arm. From the octopus's perspective, the visible fake arm occupied roughly the place where its real hidden arm might be expected to appear. But simply placing a model beside an octopus was not enough. The researchers now needed to make vision and touch tell the same story. Using plastic calipers, they gently stroked the hidden real arm and the visible fake arm at the same time. Stroke on the fake arm, touch on the real arm. Stroke on the fake arm, touch on the real arm. For approximately 8 seconds, the octopus watched one arm being touched while feeling the same pattern on an arm it could not see. Then the researchers stopped touching the real arm. They took a pair of tweezers and squeezed only the fake one. Remember, the octopus's actual body was not being pinched at this moment. The visible arm had no nerves, it could feel nothing. But the octopus did not behave as though nothing had happened, and that is when the experiment became disturbing. Part 3. The octopus defends an arm that is not its own. When the artificial arm was pinched, the octopuses displayed defensive reactions. Some retracted their real arms, some changed their body color, some changed posture or moved away, some attempted to flee from the area. These are not random details. Color change in an octopus can be part of an immediate response to threat or disturbance. Pulling an arm inward protects it. Moving away creates distance from danger. It's real body. Researchers repeated the procedure with 6 octopuses. All 6 showed defensive responses during the illusion condition. But this alone was not enough to prove that the fake arm had been accepted as part of the body. Perhaps the octopuses simply disliked seeing any object pinched. Perhaps the moving tools frightened them. So the scientists changed the experiment, and these control trials are where the result becomes much harder to dismiss. In one condition, the researchers touched the real and fake arms at different times. The eyes saw one rhythm, while the body felt another. In another condition, the fake arm was positioned in a posture that did not properly match the hidden real arm. In another, the stroking stage was removed. The illusion weakened or disappeared. The octopus did not reliably react simply because a fake arm was present. The timing had to match. The position had to make sense. Vision, touch, and body position had to agree. Only when those signals formed one believable story did the artificial arm appear to become part of the octopus's body map. But this creates an even deeper mystery. Why does an octopus need a body map at all?
Part 4. 8 arms, 1 body. An octopus has a nervous system unlike almost anything familiar to us. It has a central brain, but a huge number of neurons are distributed throughout its arms. Each arm can perform complex movements. The suckers can explore surfaces, detect chemicals, and respond to the environment. Arms can carry out actions with a level of local control that makes them seem almost independent. That has led to a popular description. An octopus is like one central brain connected to 8 smaller brains. That description is simplified, but it captures the strangeness of the system. An octopus arm can bend almost anywhere. It has no joints to tell the brain where one rigid section ends and another begins. It can lengthen, shorten, twist, curl, and squeeze through tiny openings. Imagine trying to control a limb with no elbow, no wrist, and no fixed shape. Now imagine controlling 8 of them simultaneously. To avoid tangling itself, injuring itself, or confusing its own arms with objects in the environment, the octopus must somehow keep track of what belongs to its body. That map may not look anything like the body image inside a human brain, but the rubber arm experiment suggests it may be built using a surprisingly familiar rule. When sight, touch, and position agree, the brain accepts the most convincing explanation. The arm I see being touched must be the arm I feel being touched. Therefore, that visible arm may be mine. This does not mean the octopus sat inside the tank thinking that gel arm belongs to me. The experiment cannot tell us what the experience felt like from inside the animal's mind. But its behavior suggests something important. Body ownership may not require a mammalian brain. It may have evolved in a completely different kind of animal because the problem it solves is universal. Every moving animal must distinguish itself from the world around it. But the octopus faces that problem in an unusually extreme form. And that leads to the most dangerous misunderstanding about this experiment. Part 5. Did scientists prove octopuses are self-aware? It would be tempting to say that this experiment proves an octopus is self-aware, but that goes too far. Body ownership is one component of the self, not the entire thing. Knowing or behaving as though an arm belongs to your body is not the same as recognizing yourself in a mirror, thinking about your own future, or understanding yourself as an individual with a personal identity. Their nervous systems developed along radically different evolutionary paths, yet they both can apparently be fooled by the same conflict between sight and touch. 2 very different brains may have arrived at a similar solution to the same problem. How do I know this body is mine?
Part 6. The flaw that reveals the mind. At first, falling for an illusion sounds like a sign of weakness. But illusions often reveal intelligence rather than stupidity. A nervous system does not have time to question every signal from scratch. It must make fast predictions. If you see your hand touched and feel a touch at the same moment, the safest conclusion is that the visible hand belongs to you. That rule works almost every day of your life. The illusion succeeds only because scientists create an unnatural situation in which the normally reliable rule becomes wrong. The octopus may follow a similar shortcut. That shortcut could help it control a body capable of changing shape in an instant. It could help distinguish its own arms from rocks, prey, predators, and the shifting environment around it. But for 8 seconds in a laboratory, the system was given a perfectly coordinated lie. And the octopus believed it. Not because it was simple, because its brain was doing something sophisticated enough to be deceived. So the next time you see an octopus slide through a gap, open a container, or reach into a space it cannot fully see, remember what its nervous system is solving. 8 arms, hundreds of suckers, no bones, no fixed shape, and somehow beneath all that movement, a constantly updated boundary between itself and the world. Scientists crossed that boundary with a piece of soft gel. They made an object become an arm. Then they threatened it. And for one brief moment, the octopus reacted as though something impossible had happened. The world had touched a part of its body that had never belonged to it at all. But perhaps the stranger question is not why the octopus accepted the fake arm. It is why we trust our own sense of our bodies so completely. Because the same basic trick works on us. Your brain is also building a model. Your body also feels real because sight, touch, and position usually agree. And under the right conditions, your mind can be persuaded to protect something that was never part of you. The octopus did not reveal that it thinks exactly like a human. It revealed something much stranger. A mind built on an entirely different evolutionary path may still construct a self using some of the same fragile rules. The arm was fake. The threat was not real. But the reaction was. And somewhere inside that reaction may be one of the earliest pieces of what it means to experience a body as your own. Do you think this shows that octopuses possess a basic sense of self? Or was it only a powerful sensory illusion? Tell me in the comments. And subscribe to Wild Mind Files, because the deeper we look into the animal mind, the less certain we become that human experience is as unique as we once believed.